everyone, welcome back to my YouTube channel. Today we are going to explore the history of pi, which is the first video in a history of numbers. It's in the math section, which is in the sharing knowledge section. So I got the information from a book named Mathematics: An Illustrated History of Numbers, and it was edited by Tom Jackson. So if you would like some more information, I think you should consult that book. Now you might be thinking, oh, maybe it's this type of pi. Yummy. No, it's not that type of pi. It's this one, this symbol, this Greek alphabet symbol. Now, what is pi? Pi is an irrational number. For those of you who don't know what an irrational number is, an irrational number is a number that has an infinite number of decimal values that come after it. So pi is generally said as 3.14 for basic calculations, but it took many years just to say that this was true, because you will find out later why. This was because pi was an irrational number and it had an infinite string of decimals. Later in this video, you'll find out how people found out the values of pi. So, the ratio of the circumference of a circle to its diameter is called pi. So, a ratio is a value that is compared to another value. Basically, it's like it has a value and a colon and another value. You can change that into a fraction, and basically a ratio is comparing different values, different numbers in math. So a circumference of a circle is basically the size of the line around the circle, which is the circle itself, basically. And pi is a Greek alphabet letter, as I have told you earlier in this video, and this form of pi is the uppercase form, while this form is the lowercase form. So both are accepted in math. You can write it both forms, but this is more widely known and widely accepted. Circles. The basic formula to solve for a circle's area is pi r squared. So pi, r is the radius, which is half of the diameter. The diameter is what it takes to get from here to here, or maybe here to here, but it just has to be an equal distance, and there's an infinite number of diameters in a circle. And as you can see over here, this is the circumference of the circle. The green line is the circumference, and this means squared. So the formula to solve for a circle's area is pi times the radius of the circle squared. A radius is the diameter divided by 2. So here is the history of pi. There was a Greek mathematician named Archimedes. Wait, let me check my pronunciation. No, Archimedes. Okay, so there was a mathematician named Archimedes, and he found an approximate value of a few digits of pi, taking a circle, splitting it into regular sectors, which are basically like equal sections of a circle that are the same size, making it into a polygon with curved sides, and calculating the length of it. So after that, later after Archimedes, two Greek mathematicians named these two Greek mathematicians calculated a value of pi by inscribing a polygon just inside a circle and also outside a circle, which they aren't exactly the same size, but one is just slightly bigger and one is just slightly smaller. That way the area of the circle would lie somewhere between the areas of the two polygons. They would increase the number of the sides on the polygons, which would increase the accuracy, which would be good because in math you would a value as accurate as possible is good because you want your equation to be accurate. Here is the continued history of pi. So Archimedes finished with 96-sided polygons, and the result of his calculations, so he took a polygon and he put more sides on the polygons. So he finished with 96-sided polygons, which is a lot because a square has 4 sides, and a quadrilateral has 4 sides, and a 96-sided polygon would be a polygon with many sides. So just compare 4 with 96. And change that value into the sides of a polygon. That would let you visualize the how many sides the polygon has. So the result of his calculations was a value between 3.140845 and 3.142857, which was pretty accurate at the time. In the 3rd century CE, this Chinese mathematician calculated pi as a value of 3.14159214 using a polygon with 3,072 sides. That made it even more accurate because the more sides a polygon has, the more accurate the more accurate pi is. 250 years later, in India, this person calculated pi as 3.1416 with a 384-sided polygon. The computing power available today is much more than before. Before, a computer with not much processing power took up a whole room. Now we have small computers in front of us, and it has a lot more processing power than those computers that took up whole rooms. Now, back to the topic. It allows us to calculate pi to astounding lengths. In 2011, these two people over here ran a custom-built computer for 191 days to calculate pi, and it ended up with 10 trillion decimal places over here. Look, 10 trillion digits. Even a 39 decimal value of pi would be enough to calculate the diameter of the entire known universe so precisely that the degree of inaccuracy is smaller than the radius of the hydrogen atom. So, oxygen, whatever the stuff we breathe, is mostly nitrogen and some oxygen. So, an oxygen atom is actually, let's take into comparison a water molecule. So, there is 2 hydrogens and 1 oxygen, and 1 drop of water contains trillions of those molecules, and each of those molecules has 2 hydrogens and 1 oxygen. The oxygen is significantly bigger, and the hydrogen is significantly smaller. So, take into comparison a hydrogen atom. you can't see it. It's so small you can't see it. And the hydrogen atom looks like a circle. It's theorized as a circle. The radius of hydrogen atom is, remember, the diameter divided by 2 is the radius. So the radius of the hydrogen atom is already very, 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 very small. So if the degree of inaccuracy is smaller than that, then it would be so accurate because it had 10 trillion decimal places. That would make it so accurate that you could calculate the diameter of the entire known universe this precise. So thank you for watching this video, and here is the 15 digits of pi. It's 3.141592653588979. Again, I got all this information from a book named Mathematics: An Illustrated History of Numbers, and it was edited by Tom Jackson, and I think you should look into that book if you have it, or maybe get it, and it has lots of information about the history of numbers. Thank you for watching this video. Enjoy my YouTube channel. Bye.